Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of April 3rd, 2023 this week. So we'll continue the theme of last week, thinking about the planets moving across the sky, prograde motion, moving east. We're going to look at Venus again, and we're going to look at Mars moving east and see what they guide us to this week around. We looked at this last week, and this week, the moon is very near full for most of the week. It starts the week in Leo and moves into Gemini. It goes from Leo into Virgo, and from Virgo on toward Libra by the end of the week. So watch for that. You can try to pick out some of these constellations, some of the stars, bright stars that are around the moon, but the moon washes out much of the sky. So we don't have a chance to look at some deep sky objects, galaxies, and clusters that we might normally look at. So we'll focus on the planets again here and look at some of the stars around the planets. And we'll begin, as you look west, as it gets dark, Venus is the brightest object looking west. So Venus is the big, bright star. It's high in the sky right now, as high as Venus gets in the sky almost. It's just way up there. And so it's this big, bright thing that looks like a super bright star in the evening sky as you look west. It'll be the first object that appears in the glow of the evening twilight. And it is moving toward the Pleiades. If you know the Pleiades, a fine open star cluster, bright enough, near enough, big enough to hold up somewhat to the full moon, especially since the full moon's way on the other side of the sky. And so well across the sky to the east is where the moon will be. So what you can probably see the Pleiades. If you've got a pair of binoculars, that's going to help you out just a little bit. Venus starts on the evening of the 3rd, Monday night. Venus starts about 8.5 degrees away from the Pleiades, and by Sunday, by the 9th, Venus will have tracked over just below the Pleiades, about 3 degrees. So you'll really be able to see Venus moving against this beautiful star cluster this week and closing that gap down, so pay attention to that. Now Mars, we also looked at last week, is now tracking toward Gemini, and Gemini is two bright stars, Castor and Pollux, that we talk about all the time. And so you'll see Mars. So let's start. Let's find Mars. We swing around and look more to the south as it gets dark. We swing from Venus. So Venus is over here. We swing back to Mars. Mars will be the orange object that's up here. But there's the bright red object, Betelgeuse, below Mars as well. So Mars and Castor, the bright star at the top of the pair in Gemini, you can find that sort of triangle that makes the Castor to Mars to Betelgeuse. If you know Orion, you've got the belt of Orion down here, and the shoulder stars and the leg stars of Orion. You can lock in on this. And so Mars is moving eastward as well, prograde motion that we talked about last week. So Mars is tracking toward the star Mebsuta. As the week goes on, so Mebsuta, so Gemini, we often talk about, these are very bright stars, Castor and Pollux. You have somewhat fainter stars that make up the legs of the twins down this direction. And this is a rough sketch of what that is. But you have a 3rd magnitude star. So easy enough to see, not super, super bright, not nearly as bright as Castor, Pollux, and Betelgeuse here. But Mars is tracking right toward Mebsuta this week, and it closes the gap from 5.5 degrees to 2.5 degrees. So if you hold your fist out, we do this a lot, you hold your fist out at arm's length, that's about 10 degrees across there. That's about a 10-degree angle that you're seeing. And Mars will be about half a fist width then away from Mebsuta to start the week. And by the end of the week, it will have closed that down to just a fifth or a quarter of a fifth. So it's going to cut that distance in half as the week goes on. So that's worth watching, and worth watching into next week as Mars continues to track into Gemini toward Mebsuta, that direction. So let's talk a little bit about the stars in this region. So you're watching Mars move across this direction. You're learning the stars of Gemini a little bit better as you're doing this. You'll find bright Betelgeuse down below Mars. So look just down directly below Mars and come to Betelgeuse. Now, you may or may not, we've talked about this before, you may or may not be familiar with, Betelgeuse is a bright red star. It's a red giant star. So it's this giant star with a red surface, red color. And Rigel's a very blue star, is the leg star that's diagonally across in Orion. Those are the two bright stars in Orion, or Betelgeuse and Rigel. Now, the color of the star is determined almost entirely by the effective surface temperature of the star. Now, what exactly the surface of the star is, we're not going to worry about right now, because you see some depth into the star, the photosphere of the star, what looks like the dead surface of the star to you. And how you measure that effective temperature maybe depends on what you're using, how you're measuring that color of the star, that spectrum of the star. But Rigel should look very blue to you, and Betelgeuse very red. And if you're able to see those colors, and if you take a couple of paper towel tubes and let one eye look at Betelgeuse and one eye look at Rigel, you really will see that color difference. But I suspect you don't need to do that. You might be able to see the color difference without that assistance. And so Rigel's this very blue star. It has an effective surface temperature somewhere on the order of 12,000 Kelvin, an absolute temperature scale. So very, there are stars that are hotter than that. There are stars that might have a temperature 5 times that, but those are exceedingly rare, exceedingly rare. Of the common stars that are around that you look up and see, that's about as hot as it gets, It may be up to 15 or 18 or 20, but as you get hotter and hotter and hotter, it gets rarer and rarer and rarer, those stars. Betelgeuse, on the other hand, has a surface temperature of 3,500 Kelvin. So a lot cooler, and you see that. The temperature of the star, the cooler the star is, the redder it is, and you want to look for that difference. See how red Betelgeuse is compared to Mars. Those two things are very red objects. So let's do this. We have this demonstration set up. Here's this light bulb, and I can turn the voltage up on this light bulb. And as I turn the voltage up, you see at a low voltage, it's got a nice orange-red glow that you can see there. As I turn it up, it gets yellower and yellower and whiter and whiter and whiter until it's hard to actually see it, but it's getting bluer and bluer and bluer as it gets hotter and hotter and hotter as I turn that thing up. And then I turn it back down, and it gets yellower and then oranger and then redder until you have that red glow right there, those red sort of embers that you might see there. Very, very much cooler as we turn that on down. That's what we're looking at with these stars. The hot star Rigel, the much cooler star Betelgeuse. Stars don't get a whole heck of a lot cooler than that. We don't see bright stars, common stars on the sky, a whole lot hotter than that. Very frequently, we don't see them cooler than that very much either. So if we go back up this direction, Betelgeuse up to Mars, on back across to Castor and Pollux, it's interesting to try to look at the color difference between Castor and Pollux. People don't talk about that as much. Castor in and of itself, Castor's a fantastic star. So Castor is a beautiful star. It's the alpha star in Gemini. Pollux is the beta star, although to your eye, I'm guessing Pollux might look a little bit brighter. But on old photographic film, Castor would look brighter, and that's because it's bluer. And old photographic film was more sensitive to blue. New CCD cameras, digital cameras, the opposite is true. But in old film, the bluer star would appear brighter, and so Castor got the alpha designation. These are two very bright stars, pretty similar. But Castor is a multiple star system. So Castor you can break apart into Castor A and B, and so Castor A and B are about 5 arc seconds apart. 4.5 arc seconds maybe separates them. So 4 arc seconds to 5 arc seconds. And what that means is if you have a small telescope, you should be able to split Castor A and Castor B and see those two stars pretty clearly. And we can see them orbiting each other. We've seen a complete orbit of this system. Now there's a third star, the C star that's in there. That third star is something like 70 arc seconds out there, which is over an arc minute away. And a degree has 60 arc minutes in it, and an arc minute has 60 arc seconds in it. And so this is over an arc minute away. It's well out there. It's well far enough out there that you might lose it. It's so far out there when you try to see it in your telescope. But you go out and try to find Castor A, B, and C and enjoy this binary star system. And it's a pretty good binary star system. It's worth checking out. But interestingly, each of these stars is in and of itself a binary system, and we only tell those. We can't separate those, I don't think, with any telescopes anywhere. We only know those are binary systems because of spectroscopy. We take the spectrum, we break the light up into its component colors, and we look at the spectra of these stars, and we can tell that there's 2 stars in each one of these systems. So this is actually a 6-star system, 3 binaries, or all orbiting around the system, the A and the B system here. So it's all great. But the A star, has a surface temperature. Remember, this is about 12,000. If I remember correctly, the A star is about 10,000 or 10,200 Kelvin is the A star. And the B star is more like 8,700, maybe 88, 8,900 Kelvin. let's say 8,800 Kelvin. And the C star is a little bit funny. The C star is more like 4,000 Kelvin is what the C star is. But the color is going to be dominated by these two stars. So this is going to be a bluer star. So one of the things you want to try to do is to compare this star to Rigel. Rigel's a brighter star, but if you look at Castor and Rigel together, can you see a color difference, or do they look to be fairly similar in color? But then really look at Castor and Pollux. Pollux has a temperature that's more like Castor C, something on the 4,500 Kelvin temperature range, around there. So this is not nearly as cool as Betelgeuse, but it's cooler than our sun, and so which is about 5,800 Kelvin. And so you'll see this star should look pretty yellow compared to Castor. So try to look at the difference in color between Castor and Rigel and understand that temperature difference. And then also look at Castor and Pollux, and again, use your trick of using one eye, use a tube of some sort to look, use one eye to look at Castor and one eye to look at Pollux to see if you can tell the temperature difference, the color difference. But you should be able to see that. So now that you start to get attuned to that, you can start to ask questions about the colors of stars, and if you're able to see those colors, then you can start to say, well, can I look at the color variation of the stars across the sky and start to understand the ranges of temperatures that we have for those stars. And Castor and Pollux is a great place to start and a great thing to do this week as you watch Mars tracking toward Mebsuta in Gemini, and as you think about Betelgeuse and Rigel in Orion, and don't forget to watch Venus tracking toward the Pleiades star cluster. The Pleiades is in Taurus, the bull. So it's a good week, a lot of fun stuff to see. If you like the full moon again is off in Leo and Virgo and Libra. And I'm not a particular fan of the full moon, but if that's your thing and you like to observe the full moon, by all means get out and enjoy the full moon this week. Hope you have a great week, everybody. Hope you have some clear skies, and as always, thanks for watching.